Hi students, myself D.K. Narale, working as the assistant professor in Gopal Krishna Gokhale College, Kolhapur. Today going to discuss coordination chemistry paper 7. Last video completed the introduction, distinguish between double salt and complex salt, Werner's theory and its example, applications, description of terms. In this lecture, we are completed IUPAC nomenclature of coordination compounds. IUPAC nomenclature of coordination compound. IUPAC means International Union Pure Applied Chemistry. Suggested the naming of coordination compound. It involves the following steps. Step of naming, numbering and the arrangements of ligands. Total 9 steps. First order of naming ion. First of all, the order of naming ion, positive ion named first and then the negative ion. Naming of the ligand, most of the alphabetically ligands are the naming first and listing the number of ligand in the complex or coordination compound. Numerical prefixes to indicate the number of ligands. Simple ligands suggested, mono already omitted, but di, tri, tetra, penta, hexa, hepta, nona, deca are the prefix before the number of same metal with number of attached ligands are the prefixes by di, tri, tetra. Order of naming of the ligand. Order of naming ligand is the alphabetically ligand first named and then the remaining. Naming of the complex ion and ending of central metal ion. Naming of complex ion and ending of central metal ion. The negative complex as negative complex the metal atom are named as metal with named as AAT. Example, negative complex with the copper, then the negative complex of copper, then the name as a cuprate. As similar naming of the complex is positive, then the no change in the metal naming. Naming of the geometrical isomer, the complex is cis or trans, prefixes the cis or trans of the coordination compound or complex. Naming of the optical isomers, two types of optical isomer, dextro and leo. Before the starting of naming the D or L of the complex. Naming of bridging group in polynuclear coordination compound. The first of all, bridging ligand is named as before the name of ligand shows the first of all the mu as symbol is indicate the first. Naming of the coordination compound containing metal ion. In the metal ion is example two metal in the complex attached link, then the naming di, tri, tetra as usual. In this side also in explanation, the name of the cation is formed first followed by name of anion in the first step order of naming. Example, in K2 ApCN6 K is plus, that's why potassium K plus, potassium cation first, potassium then negative ion, potassium hexacyanoferrate. Because of this complex is negative, that's why negative complex changes with the metal name as a ferrate. A complex cation by naming the ligand and then the metal ion. The oxidation state of the metal ion is written next to the metal ion in Roman number with the parenthesis. Example, in CuNH3 4 2 plus iron 4 amine ligands are named first. It is followed by copper metal along with its oxidation state. Hence the name of the complex is tetraamine copper 2 because of the in Roman closed simple bracket by oxidation state. A complex anion named by the writing ligand followed by the name of the metal ending with suffixes ate. In this ligand this complex is negative. That's why potassium hexacyanoferrate coordination pair. This bracket called as a coordination pair. Central metal atom, this ligands, this also ligands. This is the coordination number 4 plus 2, that is 6 coordination number. 4 plus 2 6 coordination. This is the mistake, and the ionizable ions and the charge number of coordination complexes. Naming of the ligand. Negative ligand with common name of negative ligand with chloride, bromide, iodide is IT is replaced by O. Then the common name is chloride, then the chlorido. Bromide, bromo. This is common bromo, chloro, iodo, fluoro. This cyano, OX hydroxo, thiosulfato, carbonato, oxido. This ligand is called as an ambidentate ligand because of the ligand contain more than two donor atom, more than one donor atom in same metal. Then the ligand is called as a, at same time ligand is called as a ambidentate ligand because of in this ligand O also donor and N also donor. That's why number of more than one donor atom in the same in complexes at same time called as a ambidentate ligand. Positive ligand ending with IUM, hydrogenium, nitronium and nitrosonium. And neutral ligands, amine, common name amine, water named as a aqua, ethylene diamine, pyridine, nitroso, carbonyl. Common name is carbon monoxide, but in the neutral ligand IUPAC nomenclature carbonyl. Name of central metal atom. Central metal atom in cationic complexes, as it is iron central metal atom, then the iron in anionic ligand complexes, then the ferrate. Cobalt in negative positive complexes, then the negative complexes cobaltate. Chromium chromate, silver arsenate, zinc zincate, nickel nickelate and platinum platinate. Few examples discussion. In this first example, positive ion first, that is potassium, then the number of ligands, the hexacyanoferrate because of the negative ligand. Potassium hexacyanoferrate oxidation state is 2 in bracket. K3FeCN6 potassium hexacyanoferrate oxidation state is 3. In this complex dichloro as alphabetically dichloro bis bis ethylene, because of ethylene is complexing agent or chelating agent, complicated ligands uh, prefixes with the bis tris tetrakis. That's why in dichloro bis ethylene diamine cobalt 3 ion. In this example, tetraamine iodine nitro platinum 4 ion. In this complex, tetra aqua dibromo chromium 3 nitrate, as it is in bridging ligand, then this is the bridging ligand. First of all, alphabetically 10 ammonium ion, that's why decaamine, bridging ligand mu peroxo 2 central metal atom dicobalt 3 ions. In this complex, tetraamine carbonato cobalt 3 nitrate. And last example, triamine nitro chromium 2. Remaining part will be discussed in next video. Thank you.